We're now looking at some harder problems on volumes. So the first one here, we've got a donut that's been created by rotating a circle. So this circle here around the y-axis, sorry. And then we're going to find the volume by using cylindrical shells. So because we're rotating around the y-axis, our thickness is parallel to the axis, so we get delta x. So our typical section, we get our radius and distance of x, and we go a point there y, and then a point there would be minus y, so the distance there would be 2y. So there's our height, that's where we get the 2y from. Our radius is x there, and we've got delta x. So our changing our volume, so our typical slice would be 4 pi xy delta x. That's where that comes from. Keep in mind that's our relationship between x and y. So we can manipulate that there. We get the y is equal to square root of 4 minus x minus 3 all squared. So that's where the y is coming from. We're going from 1 to 5 because that was our points around the axis, on the x-axis, because it's 3 there with a radius of 2 to give us 1 and to give us 5 there as our values for x. So we have to do it. This one we need to do a substitution of x minus 3, and we're going to put 2 sine x in there. So dx would equal 2 cos x d what? d theta? 2 theta, sorry, d theta. We could write x as 3 plus 2 sine theta as well, so because that's got to go in there. We change our limits of integration, so we get the x is equal to 1 becomes theta is equal to minus pi on 2, and x is equal to 5 theta becomes pi on 2. We do our substitution, and it comes down to that part there becomes 2 cos theta, which works out rather nicely. So check out the algebra there, how that happens. So this is what we get. The x is 3 plus 2 sine theta. 2 cos theta comes from that one we just proved, and dx is 2 cos theta to theta. Then we're going 4 pi from minus pi on 2 to pi on 2, which becomes it's symmetrical, so we're going to go 8 pi and make it 0 to pi on 2. Expand that out, we get the 12 cos squared theta and 8 cos theta squared theta sine theta. We're going to split it up, so the 12 cos squared theta, we're going to change to the half 1 plus cos 2 theta, and that will give us half of the 12 gives us 6, so the 6 multiplied by the 8 gives us 48 there. And our 8 times our 8 there gets put out, and we get the cos theta squared theta, and we're going to make it minus because we're going to reverse that chain rule there. So the minus 64, so that's why the plus become minus, because we're going to put a minus in there. Because the derivative of cos is minus sine. We integrate here between 0 and pi on 2. We integrate and get our reverse chain rule for that part. Do our substitution. So put our pi on 2 and put 0 in, and we only get the pi on 2 out from that. We get also that pi on 2 goes in, gives us 0, and 0 goes in, gives us 1. So that's where the 1 minus 1/3 comes from. Multiplies by the 64 pi, and we come down to our final answer there. So there's the first one. Bit of work to do. We said they were going to be harder. Let's have a look at 2 here. In 2's, we've got a little bit more manipulation. We've got a wooden beam, length 8 meters, and we've got our length there of 8 meters, and all the cross sections are rectangular, and we're talking about P and Q, and we want to have a distance here that our cross section is at h away from the base. So what we want to do is put P and Q in terms of h. So we've got 1 to 2 there, and 3 across the top, and 5 on the side there. So we're going to look at finding P first. So we'll look at this cross section here. We do a little bit of construction. We construct a little line here to split into 2 triangles. So we're going to get 3 there, when forming right angle triangles, they're similar triangles. So our 3 there, because our 2 cuts off that part. So that, because it's 5, we get 2 and 3, and we get 2 and 1 here. So, 2 and P minus 2. Our 2's, and we got our 2 there. So if that's 8 all up, and that's h, then this part would be 8 minus h. So the P minus 2 on 3 equals the 8 minus h on the whole side, which is 8. We manipulate it, multiply it through and divide, subtract and divide, we get P as that expression. We do the same thing for the top when we look there at the side 3 and the side 1. So again, we split it up and we get these triangles. So it's 1 all the way through. So we're just creating a parallelogram there. The distance there is Q, so that would be Q minus 1. We get 2, 8 for the whole thing, and 8 minus H there. So again, we set up our similar triangles, Q minus 1 on 2, 8 minus H on 8, and then manipulate that down to get our expression for Q. Calculate the cross-section PQ. Well, that would just be P times Q, which is the multiplication there, which gives us that expression. And now we want to calculate the volume of the beam. So all our expressions in terms of H, our thickness is in terms of delta H there. So we're going to take that expression between 0 and 8, because it's 8 meters long. So we start at point 0 and we end at 8. Depends on which way you want to go. We integrate this function with respect to H. Gives us 15H, 19H squared on 16, and 3H squared on the 32. And that becomes H cubed on 32 there, because the 3's will cancel. We do a substitution of 8 in there, substitute 0, well, that's going to give us 0. And our 8 goes in, gives us that, and comes down to 60 meters cubed all up for that wooden beam. So there we go. There's one that there's no X's and Y's in there. There's no axes to play with. But again, we're looking at where our thickness is going to come from. Delta H there, so we're going to get our expressions in terms of H, even though we had P and Q. The question led us through nicely to get that. But keep that in mind, if that's not there, what we have to do to try and solve this type of problem.